Hello guys, and welcome back to another episode on chemistry. It's chemistry, and of course we're going to continue our study on balancing of redox reactions. In the previous episode we did an introduction giving you all the points and the pointers that you need to know about balancing redox reactions, and in this episode we're going to take our first example. The next episode we'll take the second one, and the third one we take the third example, and we'll do some exercises that will test what your understanding on the topic. Know that this video tutorial, of course, is brought to you by the one and only best CBT practice app, the O3Schools JAMB app. It is all you need to succeed in your exam. Trust me when I say that. It has all the recent and past questions, so you don't need to bother to go and buy past question outside. All right. It has some wonderful features, such as the classroom feature that when you are trying to decipher what an answer to a particular question, you have a chat bot there that you can chat with, that you can interact with. It knows the question more than you do. All right. So, and it knows the particular question you are on. It knows the topic that question is from. So any question you ask is from that topic, it will lead you to the answer. It will not tell you the answer directly, because if it tells you the answer directly, you will not learn. So it will lead you to the answer. It's a teacher. Just imagine that I'm the one that is that chatbot teaching you. All right. I don't want to tell you the answer directly. I'm telling you what you need to know. What is this? What is that? What is this? Adding 1 + 1 together for you so that you understand better. So a wonderful feature you don't want to joke with. We also have the question search feature, where you can search for questions per topic. Let's say, for example, we are done with balancing redox reaction. You want to go and check some questions on the app. Just go to chemistry, go to question search first of all, type chemistry, then search for what? For redox reactions. All the questions on that redox reaction will come out for you. In that way, you understand all the questions that JAMB has ever set on redox, that anywhere they say question from, you'll be able to smash it and slap it away. And of course, we have another wonderful feature called the UTME challenge. It's a challenge that we conduct for all students that are writing JAMB every year. We conduct that challenge so that students can win prizes. Apart from winning prizes, you're able to see your score every weekend, because that challenge is every week, every Saturday till 1 week to your exam. All right. So as you participate in that challenge, you are seeing your score every day, just like the way JAMB releases your results according to your subject combination. That's how you are going to see it exactly. And then of course you are getting used to JAMB questions, how JAMB said that question, and of course you are building your confidence towards the main exam. And when the main exams come, it's something that you don't be able to twist the just imagine you are holding what, a chicken in your hand, and you want to twist the neck. That's exactly how we expect you to trash your exam. All right. So please, if you want to, the app is available for Android phones, so go to Play Store and download it. It will soon be available for iPhones. All right. And of course, it's also available for your computers. In case you do not want distraction during study, just download the computer version. All right. And of course, you can have both, because sometimes you may not be having access to, you don't carry your computer everywhere, but your phone is, you can carry your phone anywhere, so you can have both apps activated on both devices. But know that the activation used on your phone cannot work on your PC. All right, you have to know that. And one activation cannot work for more than one device. All right, that is that for that. So in case you want to download for your computer version, send a message on WhatsApp 09121515246. If you want to download for your phone, just go to Play Store and download it. All right. And of course, if you want to activate your app, activation is 3,000 naira only. If you want to activate, just send a message on WhatsApp to this number. Or after making payment, send your proof of payment to this number on WhatsApp, and you are going to get answered. Even though you do not get answered immediately, because sometimes I may be shooting video like this, I cannot activate app for you now that I'm shooting video. All right, so you have to be patient for some time, and of course, you will definitely get it within 24 hours. Definitely. All right, now chemistry. We are talking about balancing redox reaction. Balancing redox reactions. This will be example 1. Example 1. All right. So balance the question. Balance the equation in acidic aqueous solution. All right. We're having the question now. MnO4 minus, then plus I minus equals to I2 plus Mn2 plus. All right. So this is the question before us. We are told to balance the equation in acidic aqueous solution. Remember, I told you that redox reactions may occur in either of two solutions. All right, it's either in basic what environment or what acidic what environment. All right, so that is that for that. So now, of course, before the end of this class, I also show you how you can balance what the difference between what balancing acidic and basic. Okay, so you have to first of all balance in what in acidic before you now balance it what in basic what medium. All right, now let's see. So balance the equation in acidic what aqueous what solution. MnO4 plus I minus equals to what I2 plus Mn2 plus. All right, so now it's very simple. Remember from the previous episode, I've told you that the first step is to separate the equation into two half equations. So that I have the oxidation half equation, oxidation half equation, and the reduction half equation, reduction half equation. So this is the first step to balancing redox reactions. All right, separate the two equations into two half equations, the oxidation half and the reduction half. It is very important you understand this. Now, that means that if you need to separate these two equations into these half equations, you need to understand what oxidation is, and you need to understand what reduction is, and you need to know which of the species is oxidized or which of the species is what is reduced. Because if you know once you know the species that is oxidized, that will be the oxidation half equation. If you know the species that is reduced, the other one will definitely just become what the reduction half once you are able to identify the oxidation half. But you need to check very well. Now let's start. Let's begin so that we do not waste too much time. Okay, let's begin so that we do not waste too much time. So I give you this question: MnO4 plus I to give you I2 plus what Mn2 plus. All right, now we need to first of all separate. Number one, separate the equation into two half equations. Okay, so now what do we do now? Let's spot the oxidized species and the reduced species. Let's look at iodine. What is the charge? What is the oxidation number of iodine here? The charge on iodine here is what? It's -1. Okay, as you can see evidently, right? Now, check for the product side, the charge on iodine. Iodine is here now, I2. The charge here is now 0. Okay, because this is It's an element in in the free state. So it has a charge of 0. That means this iodine actually increase in oxidation number, because the oxidation number of iodine change from -1 to 0. You ask yourself which number is bigger, 0 and -1, which one is bigger? Some of you will say, some of you that have coconut head will say -1 is bigger than 0. All right, and if I'm there now, I will press conk on your head. Okay, so please, 0 is far bigger than -1. All right, 0 is a bigger number, it's a larger number than -1. That means that iodine has increased in oxidation number, resulting from loss of electrons. All right, so it is iodine has lost electrons and the oxidation number has increased, because from the definition of oxidation, we said oxidation is the loss of electrons, right, resulting to an increase in oxidation number. Okay, so from -1 to 0 is an increase in oxidation number, and it is because iodine has lost electrons. Okay, so you need to first of all understand that. Now we have seen that iodine is the oxidized species, but we need to check this one also. Okay, now in case there's a misconception with the question. Now, what is the oxidation state of Mn here in this MnO4? I give in MnO4 minus the oxidation state of Mn. Let's calculate. We have done. I've already told you. I've already given in one of the episodes. We've already talked about how to know the oxidation state of elements in compounds. So for those of you that don't want to watch all the episodes, that's a problem. Okay, or everything you need to sustain your exam is on this channel, so you do not need to bother. Okay, so now let's see. Let's calculate for Mn. So Mn then plus what is the charge of oxygen? That is -2 plus into 4 is equal to -1 is equal to the charge, because this is a radical, right? We are given a charge, so everything will be equal to this charge. Now having Mn, then -2 times 4 is is -8, right? Minus times plus is minus. Mn minus 8 is equal to -1. Now that means -8 will cross to this side. So I'm going to have Mn is equal to -1 plus 8, which is equal to what now? 7. Okay, so that means that the oxidation state of manganese in the reactant side, right, is 7. Now, but the oxidation state of manganese in the product side is what? Is 2. Now, that means the oxidation state of what? Oxidation number of what? Manganese has decreased from 7 to what? To 2. Does that show reduction or oxidation? That is what reduction, because we define reduction, right, as gain of what? Of electrons, leading to a decrease in oxidation number. That means oxidation number will decrease because what? The element has what? Has gained what? Electrons. Or the species has what? Gained what? Electrons. Or the atom has what? Gained what? Electrons. All right. So now that we are sure that iodine is the oxidized species and manganese is the what? Reduced species, then we can proceed to the next step. Okay, so we have to separate them into 2 half equations. That means the oxidation half equation will be what now? That is I minus to give you what? I2. Okay, this is the what? The oxidation half equation. Now, the reduction half equation now will be equal to what? Now you have what? MnO4 minus, then to give you what now? Mn2 plus. So we'll be able to separate sufficiently the 2 equations into 2 half equations, the oxidation half equation and the reduction half equation. So now what do we do? The first step is to balance the atoms. Okay, balance the what? The atoms. Like from here now, we are saying that there's 1 atom of what? Iodine here. Here there are 2 atoms of hydrogen here. So for of what? Of iodine here. That means we need to balance what? This what? Atoms. Now for the reduction half, all right, we have 1 atom of manganese, 1 atom of manganese. So manganese is what? Is balanced. Okay, so now we need to balance these atoms. So for the oxidation half, all right, I'm going to have what now? 2, we have to add 2 here so that here will be balanced. So I have 2I minus is equal to what now? I what? 2. So this is now balanced. But for the what? For the reduction side is what? It's already what? Balanced. Now, I told you that the next step is to what? Is to balance the equation by adjusting coefficients, adding H2O, hydrogen ion, and what? And electrons in this what? Order, or in the order I just what? Mentioned. Or in the previous episode, you can see what? All the steps. I've thought about all the steps that you need to balance redox. Okay, so now let's see. Now the oxidation half is this, reduction half is this. Okay, now let's see. The oxidation half, is there anything like oxygen here? No. Because to balance oxygen, we need to add the appropriate number of what? Water molecules, right? To balance oxygen, we add the appropriate number of water molecules. Excuse me. Now, but on this side, on this oxidation half, there's nothing like oxygen. But on this reduction half, there's what? Oxygen here. We have what? 4 what? Atoms of what? Of oxygen. Now we need to balance for this reduction half by what? By adding what? The appropriate number of what? Water molecules to the other side. Right, to the other side. Now we ignore the oxidation half because there's no oxygen. If there was oxygen there, we'll have added what? Water molecules to it. Is that clear? All right, now let's see. Now to balance that reduction half, now it will be reduction half again. Reduction half. All right, I'm going to have add what? The appropriate number of water molecules. So I'm going to have MnO4 minus, then that will give us what now? Mn2 plus, then plus what now? How many water molecules are we going to add now? I'm going to have 4 water molecules because there are 4 atoms of what? Of oxygen here. I'm going to have 4 H2O. So that there's 4 atoms of oxygen here, there's 4 atoms of what? Oxygen here. So we have balanced what? The reduction half by adding the appropriate number of what? Of water molecules to the other side. Now, what's the next step? We balance the hydrogen. Now we balance the hydrogen next. Now on the oxidation half, there's nothing like hydrogen there. Also, is there? No, there's nothing like hydrogen on the oxidation half. But on the reduction half, there's what? Hydrogen here. All right, that means that what we need to what? Balance what? The hydrogen first by adding what? The appropriate number of what? Of hydrogen atom to balance it. So now we have 8 atoms of hydrogen here. Here we have none. So we need to what? Add what? 8 atoms of what? Hydrogen ions to this what? Left hand side, or to this what? Reactant side. Okay, so to balance the reduction half again, reduction. The reason why we're not talking about adding H to this one is because for now, because there's nothing like what? Like hydrogen in this what? In this equation. So we'll leave it also first. So for now, let's balance the hydrogen. We're going to have MnO4 minus, then plus what? 8 atoms of hydrogen ion, then to give us what? Mn2 plus, then plus what? 4H2O. Okay, now that is that for that. Now we have balanced what the reduction half. MnO4 minus 8 hydrogen ions equals to Mn2 plus what? For 4 plus 4H2O. So what do we do next? So what we do next now is to what? Is to add up the charges. We add up the charges so that what? We'll be able to what? To balance the what? The charges on both sides. Okay, we need to balance the charges of what? On both sides. So we need to add up the charges and then add the what? The appropriate number of what? Electrons to the more positive side. Okay, so because of the space of the board, I'm cleaning this part. I'm cleaning even the topic. All right, so let's have more space. I'm over cleaning what this subject. Let's have more space. Okay, so now this is the reduction half. We want to balance what? The electrons. So we are balancing electrons now. Balance the what? Electrons. And how do you balance the electrons? You add up the charges on both sides. Now, what is it? What is the total charge on this reactant side here? You have 2 minus. That means that what? 2 what? Minus 2 is total charge on what? On this left hand side. On this right hand side, what the total number of charges is 0 because iodine is in the what? Is in the free state there. So this is minus 2, this is 0. The more positive side is what? Is this 0. Okay, so add the appropriate number of electrons to this side to balance what? The electrons. So what you simply do is to add what? 2 electrons because what? They are what? They are minus 2 what? Electrons here. So you balance. So to balance the what? The oxidation half now. Oxidation half. All right. So I'm going to have what now? So rather, I'm going to have 2I minus then is equals to rather is equals to I2 plus what? 2 electrons. Okay. So you are balancing the what? The oxidation half by adding 2 electrons. Okay. So here now is now 2 minus 2 total charge. Yes, minus 2 total charge is now balanced. Okay, now the reduction half, let's calculate. Now, yeah, the reduction half, what is the charge here? Yes, what? Minus 1. Okay, so sorry, this is the reduction half plus 8 hydrogen atom, not this one. Okay, now this is where we stop for reduction half. So that is where we are going to check our charges from. All right, now we have done with that. Let's see. What is the charge on MnO4? It's minus 1. What's the charge of hydrogen here? Is plus. That is 8 plus. Then that means plus 8. Total charge, yes, minus 1 plus 8 is what? Is 7. Okay. Then on the right hand side now, the charge on Mn2 plus is what? Is 2 plus. Then what's the charge on what? On H2O plus 0 is 0. Okay. So 2 plus 0 is what? Is 2. But that means that what? That the more positive side is what? Is the left hand side. This side is more positive than what? This side. That means, and by how many electrons? The left hand side has 5 more electrons more than the right hand side. So you add what? 5 electrons to the more positive side. 5 electrons to the more positive side. All right. So having what? Decipher that, you will now come up and say reduction half. Reduction half is equals to now I'm going to have what? MnO4 minus then plus what? 8 hydrogen ion then plus 5 electrons will give you what now? Mn2 plus then plus what? 4H2O. All right. So that is that. Now we have balanced the reduction half by adding the appropriate number of what? Of electrons. Okay. Now, what is the next step to do? Like I said, the next step is to balance the electron, all right, so that they are made equal, because they must be made equal by multiplying with what? Appropriate integer. Okay. So what you do, you multiply what? Both the reduction half and the oxidation half by the coefficient of by the least common multiple of the coefficient of what? Of both what? Half equations. Now, how many electrons are here? 2 electrons. How many electrons are here? 5 electrons. We need to make 2 of them the same so that they have the same number of electrons. So what we do, we can multiply this equation. If we call this one equation 1, for example, equation 1, and this one, let's say it's equation what? Equation 2. Okay, so we can multiply this equation 1 by 5 and multiply this equation what? Equation 2 by what? By 2. so that the number of electrons here will be 10, the number of electrons here will be 10. All right. So what we do, multiply equation 1 by what? By 5, and equation 2 by what? 2. Okay, to make the number of electrons was the same. Now 2i times 5 is what? 10i minus. Are you there? Then it's equals to the other side now. 5 times i2 is what? 5i2. Then plus 5 times 2 is what? 10 electron minus. Okay, we get that. So now to multiply this reduction half by 2, now I'm going to have 2MnO4 minus, right? Then plus what? 2 times 8 is what? 16 hydrogen ion. Okay. Then plus what? 2 times 5 is what? Is 10 electrons. So that 2 of them are now 10. Okay. That is our aim. Then you now get what? 2 times Mn2 plus is what? 2Mn2 plus. Then plus 2 times 4 is what? 8H2O. Okay. Now, this is where we have gotten to. And of course, after getting this, what do we do next? The next step on the last episode we did is to what? Is to add up what? The two half equations. Canceling out what? The electrons to have one balanced equation. We add up the two half equations, canceling out the electrons to have one balanced equation. So if we're doing that now, adding up and canceling, all right. So now we're going to see here that what on this reactant side, I'm going to have 10i. Let's add. I'm going to have 10i minus, then plus 2MnO4 minus, right? Then plus 16 hydrogen ion. Okay. Then this 10 will cancel what? This 10 will cancel. There we go. Then that will give us what now? What is on the product side now? We are done with the reactant side. 10i, look at all the things in the reactant side. 10 has gone already, 10e has gone. So 16H plus 10i and 2MnO4 are what we have on the reactant side. Okay, so that's these are what we have there. Now for the product, we're going to have 5i2, okay, then plus what? 2Mn2 plus, then plus what? 8H2O. All right, so this will now be our balanced equation in acidic aqueous solution. Finish. You see, very, very, very easy. This is a simple thing we have been trying to do since. And the reason why it's taking this long is because I'm trying to explain. If I'm not explaining, you already know. So you need to practice more questions so that you can gain your speed and understanding. All right. So now that is that. So this is balanced in the acidic aqueous solution. But how do we know? Should we just after getting this, should we just rest? No, we don't rest. You have to check for balance. You have to check for balance. And how do you check for balance? You add up the charges. Add up the charges on on the left, add up the charges on the right. If they are equal, then the equation is balanced. But if they are not equal, something is wrong somewhere. All right. So now we need to please make sure you like this video. Liking this video will make other students find this video easily. If you know what made a pass, please like this video. All right. And of course, if you have not subscribed to this channel, what you do no good. It's very bad. Please click on that red subscribe button. Subscription is free. You are not paying anybody for subscription. Just click on that red subscribe button so that once we publish a video, you will get a notification on your phone. Please do that immediately. All right. And do not forget to share. Share this video to your friends. Make sure you share to somebody. Make sure you share this video to somebody so that the person learns. All right. Now let's do this. Now this is let's check for balance. Now how many what's the charge on what? Total charge here is what? Is 10 what? Is minus 10, right? 10 times minus 1 minus 10. Then plus total charge here is what? Is minus 2. Okay? Total charge here is what? Is 16 plus 16. 16 times 1 is what? Is 16. 2 times 1 is what? Minus 2. 2 times minus 1 is minus 2. Then 10 times minus 1 is what? Minus 10. Then let's see this right hand side. Here is what? Is 0. This is the what? This is a free atom. It's element in the free state. Okay, 0. Then plus 2 times 2, that is 4. Then plus what? 8. This one is also in the free state. So we have 0. Now let's add minus 2. Minus 10 minus 2 is what? Plus times minus is minus. So minus 10 minus 2 is what? Minus 12. Minus 12, then plus what? 16. Then it's equals to what? 0 plus 4 plus 0 is what? Is 4. 12 minus 12 plus 16 is what? Is 4. So 4 is equals to 4. You see that what our equation is balanced. Is balanced. So you can now smile. Ha! My effort have not been wasted. All right. Now, if we are told that we should balance this equation in basic solution, all right, in basic aqueous solution. In the question we are giving initially before I wipe the board is in acidic aqueous solution. If we are told to balance the equation in basic aqueous solution, what do we now do? It's simple. How many hydrogen? Look for the number of hydrogen ions we have in the what? In the balanced acidic equation. We have 16 hydrogen ions, and you know that what? Hydrogen ion plus hydroxide ion, all right, is equals to what? Is what gives us water. Okay, that means in the basic solution, we are looking for what? The number of what? Hydroxide ion we will add to this hydrogen ion to turn it to water. So we need to turn this hydrogen ion to water molecule by adding the appropriate number of what? Hydroxide ion. Okay, so since we have 16 what? H plus, that means we need 16 OH to what? To turn it to water. And if we are doing that, we're adding what? For what? For both. We're adding on what? On both the reactant and product side. So this equation, why this equation is balanced for acidic medium, for the basic medium, we need to what? Add what? 16 OH. So I'm going to have 10I plus 2MnO4 minus, then plus now 16 H2O, right? We have already added 16 OH to make it 16 H2O. Then will now give us now 5I2 plus what? 2Mn2 plus 8H2O plus 16 OH minus. Okay, so you add it to both the reactant and the product side. That's why it's appearing here. Okay, now this now looks like 160 H plus 16 OH minus. So now what we do, we cancel out. We have 8 hydrogen atom here. Sorry, 8 water molecules here, 16 water molecules here. So if we cancel this one, then there will remain what? 8H2O. Okay, so the overall equation in the basic medium, the basic what environment will be 10I, sorry, with 10I plus 2MnO4 minus plus 8H2O to give you what now? 5I2 plus 2Mn2 plus, then plus what? 16 OH minus. Okay, so this will be the balanced equation in the basic medium. Okay, so it's very simple to understand. All right, so this is where I'm going to stop in this first example. In the next episode, we'll solve another example, and then we'll talk about, I think we'll have 2 more examples to solve, and then we're done with what? With balancing redox reactions. Thanks, and I'll see you in the next episode.